Good evening, ladies and gentlemen. Welcome to the 15th Nuremberg Lecture. One of the criticisms one might raise about our speaker tonight is that he's a bit of a dilettante. In fact, I think I heard that presented to me, and my response was, well, yeah, he is a dilettante, but he's a very good dilettante. And in fact, he's such a good dilettante, I think the term polymath is in order. Someone who really is capable of doing many, many things. And in fact, that's one of the greatest weaknesses in our ability to cope with subjects like math and physics and so forth, and integrate them into the broader society, is because where people tend to be very narrow, and there's not a ability to handle things well. So we really need our polymaths these days. And I'll give you an idea of the kinds of things he's done. I mean, aside from what's been advertised, which is that he was a special advisor to Margaret Thatcher, actually at 10 Downing Street during the Thatcher years, and he's been involved in many wild tales of that type, and hopefully he'll tell us some interesting things of that sort. He also has had a history as an amateur mathematician, and of course we got into a discussion about what constituted a mathematician. And mathematician, of course, in my view, and I know a lot of mathematicians feel the same way, is all you really need to do is love mathematics and come up with something new and interesting in mathematics, and that makes you a mathematician, and we don't care about any of the rest if you engage our interest. So that, to my mind, qualifies him in that respect. And he really did that. I mean, he went out, invented some puzzles. So he's a puzzle maker as well as being a special advisor to Margaret Thatcher. And he invented one puzzle, the eternity puzzle, which he then challenged the world and said, okay, if you can solve my puzzle, I will offer you £1 million, which I thought was a pretty, bold and audacious claim. And apparently it took two Cambridge mathematicians almost 2 years to do it, but they did actually do it. But that wasn't good enough for him, so he made an Eternity 2 puzzle where he had a $2 million prize, and they didn't get that one. So these things had actual solutions. He's also well known for his books on Sudoku X. It's his own version of Sudoku. I think he's written 5 books on that. I also found out during his visit here that he can do shorthand at 100 words a minute. He is a pianist, but he won't admit to that. But he seems to have been able to beguile people with Chopin, and I think anyone who can do Chopin even badly is already way above my abilities as far as being a pianist. And it just really goes on from there. He's an architect. He builds houses. And every one of the things that I've encountered that he's been involved in, he does very well. And I don't agree with him on everything, and we argue about some things. And I have to admit that sometimes he actually is right. But nonetheless, he's very congenial about his arguing. And I think you'll find that he may take some kind of bold position of one kind or another, but he is definitely open to other people's thinking on things. And as long as you're prepared to justify what you have to say in a rational way, then he's really a real joy to talk to and to argue with about any number of things. He's interested in almost everything. And of course, he's most well known, regrettably, for his connections with climate business, because I think it just kind of swamps out all of these very fascinating abilities that he has. And so we'll spend a little bit more time on these other things, although we'll certainly mention some things. The climate business will come out as an example of some of this stuff, but it won't primarily be the topic of discussion tonight. So I think I've rambled on enough about our speaker, but I would like then to invite the Right Honourable Lord Christopher Monckton, 3rd Viscount of Brenchley, to come up to give his speech.
That's it. My lords, that's me, distinguished professors, doctors, lecturers, ladies and gentlemen, students, and anybody else. After that outstanding and entirely flattering and gratifying but mendacious introduction, I just can't wait to hear what I'm going to say. Well, my subject is the Courtier's Conundrum. And this lecture is given in honour of a man that I should have loved to know, Paddy Nerenberg, who was, I should say, Chris Essex's distinguished predecessor as Professor of Applied, or as the pure mathematicians call it, impure mathematics here at the University of Western Ontario. Now, mathematics, the language that Paddy Nerenberg spoke with such fluency and fire, is the language which existed even before God said, "Let there be light," and there was light. And only then, a few fractions of a second after that, did the laws of mere physics come into play. Mathematics was there before. And this great language, which one of you here today in the Department of Pure, or as the applied mathematicians call it, inapplicable mathematics, mathematics is the greatest achievement of the human intellect. And the queen of the sciences, as it is known, is not to be spat upon, is not to be brought low by being dragged into politics and kicked about as though the attempt to reach beautiful truths, which are its object, were of no consequence and were all repealable and subject to mere transient political fads and fashions. Now, the Courtier's conundrum is this: how can the inexpert advisor to a statesman advise that statesman expertly? If government were simply a matter of leaving it to the experts, there would be no need for politicians, and some people would say that was a very good thing. However, if the politicians are to keep control in the name of those who elected them to govern, then they must be willing and able, through their advisors, to second-guess the experts. This does not mean that the experts are always wrong, but likewise it is foolish to assume that they are always right. Sometimes fashion can get in the way of thought, and when it does, the consequences are expensive and can be fatal. So what I'm going to do is to invite you, as it were, to be the Prime Minister of the United Kingdom. Imagine that we are at an agreeable weekend at Chequers. The pressure is off a little, but this is Margaret Thatcher. You're all pretending to be Margaret Thatcher. And she likes to be intellectually stimulated at all times. And she has asked for a briefing on global warming, but she doesn't just want that. She wants a little bit of mathematics thrown in purely for entertainment, because she was riveted by new ideas. Being a scientist herself, she was familiar with the language of the sciences, that is mathematics, and she delighted in using it and delighted in those of her advisors who were willing, however inexpertly, to have a go. So what you're now going to get is, in effect, a prime ministerial briefing in which I will be illustrating some of the techniques that each of the 6 policy advisors she had would use in order to make sure that she was briefed soundly and not too inexpertly on matters where, in our opinion, the experts had indeed gotten it wrong. Turn this round. So what I'm going to do is to start, because this would amuse her, by looking at the first mathematics that I actually had to use in earnest as a trainee classical architect at the University of Cambridge. And we're going to look at the conic sections. There they are, the circle, the ellipse, the parabola, and the hyperbola. And these four sections were used in particular in the earliest of the three Greek orders of architecture, the Doric order. And here you will see how they were used. The parabola was used to give a slight, very, very gentle upward curve to the stylobate, the floor on which the columns stood. This was to correct what would otherwise have been an optical illusion of the building sagging in the middle. Then, at the capital of the column, you will see there's a cushion, or echinus, and that had a profile of a hyperbola, near enough. And where then is the ellipse? Well, you'll see in that column turned on its side up there, there is a truncated semi-ellipse that gives to the Doric column its characteristic diminution. It gets narrow from bottom to top, from foot to neck, and it also bulges a little on the way. And that is a very shallow, truncated semi-ellipse. Now, there are two schools of thought about this in the literature. Some say that it's too mechanistic to assume that all these forms were explicitly usages of the conic sections. Others say, no, this is what was the truth. And this, being a debate on a matter of no particular consequence, is conducted, as I think all academic debates should be, in a thoughtful and gentlemanly fashion, and it's been running for at least 70 or 80 years in the literature without any great conclusion having been reached. So this is academia exactly at its best. And here is the Temple of Concord at Paestum, which is a canonical Doric building. And you'll see there that I have used my architectural drawing program to superimpose upon the two centermost columns at the front of the temple there the truncated semi-ellipse. And as you will see, it's quite a good fit. In fact, it's a very good fit. Now, why do I think, therefore, that the mechanists, rather than the artists, are right in this debate? Well, here is an ellipse. And unlike the hyperbola and parabola, where you need a directrix and all sorts of complicated mathematics to draw one, the ellipse is easy to draw. All you do is take the semi-major axis, that's the red horizontal line that takes you halfway across the ellipse, take one end of it up to the top end there of the semi-minor axis in the center of the diagram at the top, and then draw an arc, and where that arc crosses the major axis, those are what are called the foci of the ellipse. Now, if you had a sand table, as you would in ancient Greece, then you would put two pegs very firmly rooted at the foci. And then you would take a piece of string and you would wrap it round the two foci and then out towards any point you liked on where you wanted the edge of the ellipse to be. And then with your strigil, keeping it tight, you would simply draw the ellipse all the way round. Because, as you'll see, triangles A, B, C, and D there all have perimeters of the same length. So it's very, very easy to draw an ellipse. And I once had to describe this to Scottish builders over the telephone because they were laying out an elliptical garden for my lovely wife in Scotland, and I was in Cyprus. So I told them this, and they said, "Where do you learn all this stuff?" And I said, "At university, of course. That's why we go there." And here is that elliptical garden, and this was built over a period of 3 years by a retired stonemason who was devoted to the Carey estate, absolutely loved it there, and he made not a bad fist of it at the age of 83, heaving large stones about. And here is one of the classical buildings that I'm designing at the moment. It looks big, as all classical buildings do, but in fact, that is only 11 meters wide by 8 meters high. It's what we would call a cottage orné. It's a tiny cottage which is going up on one of the great Scottish estates. And it will have inside it 4 bedrooms, each with its own bathroom. It will also have a kitchen. It will have a very good-sized dining room. and also at the top, behind the pediments there, an enormous circular library 40 feet across. And there I have used this technique of drawing ellipses to give the Doric columns their characteristic shape. Well, now, what I'm going to do is to look at a few more amusing things in mathematics that I have stumbled across. Some of them are new, some of them will be old, and you'll have to put up with that, but they're new to me. So as you can see, why it was that when the 6 members of the policy unit, none of whom were scientists, were asked to give advice to the Prime Minister, it was I who usually gave the advice on scientific questions, second-guessing the scientific experts. This did not mean that I was cleverer than they was, merely that I had developed various techniques for trying to find out whether they were right. There are certain things you can do, and I'm going to show you a couple of examples of this later. But for the time being, Prime Minister, I'm just going to entertain you a little with a few entirely trivial, inconsequential mathematical delights. Now I'm going to start with the properties of circles, and the circle would have occurred to early man when he was out with his lady proposing to her in the moonlight. Here is the moon at its recent perigee, photographed by Tim McCord. I lifted this off the internet, so if you want a copyright fee, I have 2 words for him as a Christian: tough luck. And so the idea of the circle has been around ever since the moon has been around for us to watch. And here is one startling property of circles that I came across when I was fooling around a few years ago. And it's an unexpected connection between circles and power series. And if you start at the left there with n equals 1, and then here we're going to, in fact, n on this, in this diagram is 1.5. But 1.5 to the power of 0 is 1. So your circle will always start out being 1 at the left. And then 1.5 we go, then we go 1.5 squared. And these are the diameters of the circles, each of which touches in a line. They're tangent to one another. And when you do that, you get this unexpected result that the lines tangent to their edges, top and bottom, are straight lines. An entirely unexpected result. I haven't seen it in the literature before. There are many learned mathematicians here. If you have seen it before, do put me out of my misery. Otherwise, tell me what a clever boy am I. Now, here is a puzzle that was first set by Henry Ernest Dewdney, England's greatest puzzlist, in about 1907. And it was one of the Canterbury puzzles, as he called them. And this was the ploughman's puzzle. They were all on their way to Canterbury to the shrine of Thomas à Becket, and they told each other puzzle stories on the way. And the ploughman's puzzle was, how could he plant 16 trees so as to get 15 rows with 4 trees in a row, and all the rows had to be straight. And this is Dewdney's answer. It's one of many that you can find, and your challenge, if you like to take it up, is to see how many other ways of putting these trees together to give this effect you can stumble across. It's a nice exercise in a bit of lateral thinking. Now, when I looked at this puzzle, I thought to myself, I wonder if this principle works if we scale it up and have 8 points around the outside instead of 5, as here. So in those days, computers hadn't been invented, so with a ruler and compasses, I painfully marked out the octagon and then began drawing lines rather busily, and this is what I got. And sure enough, you get this very nice connection. Here you have 24 lines with another 4 I haven't drawn in that go through the center, and I'll explain why I haven't done that later. And 24 little places where they meet, the nodes. And here is another startling property of circles. This one is quite delightful. Again, I haven't seen it anywhere, but then I'm just a layman, so what would I know? But when I came across this, I was really pleased with it, simply because it's such a beautiful idea. Here we have what is essentially a way of getting straight lines to intersect in various interesting ways. And on the other hand, how do we decide exactly where these nodes should go, short of doing it the hard way? Well, here, what's this? You simply take a circle, take a point on that circle, and then rotate and translate that circle at intervals of 45 degrees. And wherever the resulting circles intersect, that's your node. And so you'll see they are exactly in the same places. Don't you think that's rather beautiful? Yes. So come on, give it a round of applause. We'll be testing you on this later. So it occurred to me that I could make a board game out of this concept. And I spent a lot of time in Cyprus, and the city of Nicosia is as unusual as one of your coins in that it is arranged as an endecagon. It has 11 sides, and there are bastions at each corner, 11 bastions evenly spaced around the more or less circular walls of Nicosia. So I thought, let's use that as our grid, and then you get there 44 streets, if you like, in the city of Nicosia, and you have 77 streets, 44 forts, and you have exactly 7 streets meeting at each fort, and exactly 4 forts on each street. Now this gives the possibility of inventing a charming game, which I marketed about a year before I went into number 10, under the modest name Supermind. And it sold gratifyingly well. And I got my first royalty check, not for writing a book or giving a speech, but for inventing a game that did very nicely on the toy market. So the second challenge I would like to offer to you today is to try and find sets of rules that will give a good strategy game on boards of this kind. Here, for instance, are the rules of the game that I came up with. They're very simple. You can learn them in 5 minutes, but the strategy is more complex than chess, particularly if you have 2 generals, each with 2 armies, shooting at each other on this city of Nicosia. So they mustn't shoot themselves or their opposite, they mustn't shoot their neighboring army, their friendly army, but they must shoot the armies of the other side. This introduces delightful strategic complications. Can you come up with better rules than I can? Because if so, get in touch, monckton@mail.com, and we'll get rich together marketing the next version. And just to make it more fun, there's the 8 board. Now you see why I didn't put the lines going through the middle, because that would have given an unequal distribution of forts meeting at each road. And I wanted it to be equal because that is ideal for this kind of strategy game. And likewise, you can go to the 11 we've just seen. You can go even to, there are 90 forts on the board. That begins to get quite difficult to see what you're doing when you're playing. If you make the board big enough, you can still do that. And then you can have half a dozen players going at each other. Then you can even go to 120 or 144. And the art here is to make sure that with more and more lines, more and more roads crisscrossing, you still have room to put the forts in there so that they don't override roads that they shouldn't be on. So there are a few possibilities for the playing boards for this game. It's down to you now to see if you can write me some really good, challenging, exciting sets of rules. Now we're going to look at the eternity puzzles, about which you've heard a certain amount already, how I got caught and had to pay out £1 million to 2 Cambridge mathematicians, one of whom, it turned out, had been using the cryptographical computers at the GCHQ for cracking this problem, so he did have quite an edge over most folk. But the great thing is that by that stage I had sold 500,000 of these puzzles at, I think it was 35 sterling each. And so you can do the math for yourselves, that's another little challenge for you, and work out how difficult it was for me to find the £1 million prize. And how did this puzzle come into being? Well, if we start with this very well-known puzzle, the pentominoes, that's at the bottom of the screen there, and you'll see how you get to the pentominoes, how you build them up. And these are squares, tessellated, so that the edge matches edge. And you start off with 1, then you can put 2, and there's only one way of putting 2. Then you have 3, there are 2 ways of arranging 3, 5 ways of arranging 4, and then adding the 5th one gives you 12 and only 12 distinct shapes which can be rotated and reflected at will. The pieces can go two ways up. Now, if you take a, shall we say, a 6 by 10 grid, then putting those 12 pieces into that grid, you'll find it surprisingly difficult. And yet there are 2,339 distinct ways of putting those 12 pieces into that 6 by 10 grid. And you can then go to something more complicated. You can take one of the semi-regular tessellations. You see these a lot in Islamic art because they weren't allowed to have representational images. And here I've broken up this tessellation into 20 distinct pieces. And the idea of these pieces is that they will go against each other in lots of different ways so that you can tile the plane with these pieces, 20 distinct pieces. And you can invent puzzles of this class all by yourselves, as many different puzzles you can dream up. You can use the regular or semi-regular tessellations. You can use all kinds of weird and wonderful shapes, provided that they tile the plane in some way. And then your art is to find a rule for prescribing the pieces that makes some kind of sense. Here you can see effectively what I've done is there've got to be two equilateral triangles and two isosceles triangles, which are halves of a square. Each piece must have those, or you can have 1 and 3 or 3 and 1. And the complete set of pieces that is thus composed is in front of you now. It's a 20-piece jigsaw puzzle with the Viscount's coronet in among them, just to remind you who did it. And here are two of the shapes that you can make by those 20 pieces. You can use those 20 pieces in about 1,000 different ways in each case to make the heart shape on the left or the heart shape on the right. And I devised this puzzle originally for my lovely wife, Juliet. She said, "You're always making puzzles. Why don't you ever make one with a heart shape?" And I said, because a heart shape is an absolute nightmare. It's very difficult to do anything satisfactory with it. And she said, well, you've just got to try a little harder. And so that is how this puzzle came into being. And if you are proposing to somebody, ladies and gentlemen, then giving them one of these, perhaps made in silver, it's not terribly expensive to do that, will win her heart until she tries to solve it, and then there might be trouble, because they're not easy to solve. And there are various other shapes into which these same pieces can be fitted. The one on the left, the one on the right, and the pair on the top there. That's a very difficult one, but the 12 pieces can be distributed between those two shapes if you want to do it. Now then we come on to the eternity puzzle itself, and this is based on the principle of putting together halves of an equilateral triangle. And here you'll see all the different ways, there are 14 of them, of assembling 3 halves of an equilateral triangle into pieces following the grid rules that make the puzzle fit together in many different ways. Now, the defect with this design, as you see it now, is that the pieces are too sharp. Those 30-degree angles are very sharp, and some kid might cut itself on that and then sue me, and I'm disinclined to face a kid in court because you know who's going to win that. So what I did was to restrict the pieces in such a way that the sharpest angle was 60 degrees, and if they stabbed themselves with that, well, that was down to them and not to me, and I had done my due diligence by making it not less than 60 degrees. And this puzzle is essentially 209 pieces. They can go either way up, they fit against each other in many different ways, and they form a very nearly regular dodecagon, 12-sided figure. And here is the person who didn't win it. He came second. He was too slow and too late. Also, he was a thoroughly nasty piece of work, and I had great pleasure in writing to him at the appropriate point and saying that somebody else had beaten him to it. And the people who did win it were very nice people, and I can't say I was delighted to hand over a cheque for £1 million, but nevertheless, they had earned it because this was a difficult puzzle. And Eternity 2 was then that much harder. It went on sale for 4 years, nobody solved it, and so I got even richer than I already am. And that's so you can play with mathematics and yet make a profit out of it and give people a lot of fun along the way. And then there was Sudoku X. You know the traditional Sudoku grid. The only difference is that I have made sure that the 9 boxes in the diagonals each also have to contain the numbers from 1 to 9, just as the rows, columns, and the boxes do. And so your task on this puzzle, little challenge for you all, is to see if you can work out how much rarer this type of grid is than the type of grid where you can arrange the numbers 1 to 9 without the X. That's quite an interesting problem in combinatorics. Professor, I hope you'll be setting that to your students in their exam coming up. He says yes, so watch out. And so if we then look at a more complicated version, here is a 16 by 16 puzzle in which not only do you have the rows, the columns, the 4 by 4 boxes, but also the 2 by 8 and 8 by 2 boxes and the 2 diagonals. Now, the advantage of having so many different groups like this is that you can reduce the number of starting digits that give people a clue. And if you reduce them maximally, so the solution is still possible strictly by logic and no guessing at every step, then it could take up to a month to solve one of these by hand. This is a serious puzzle. But for the Daily Mail, for the general reader, the puzzle I set is this one. It's very charming. It's just 6 by 6. And you have some 3 by 2 boxes, but not 2 by 3. That's not possible. And you also have the X in there as well. So I had a lot of fun with this. 5 books of puzzles. The first of them actually sold 100,000 copies. So that too has been an enormous entertainment. And now we're going to look at mathematics and policy, because one of the problems that the inexpert advisor has is how can he advise in a way that will make sure that the Prime Minister takes him seriously, even when the experts have all told her something else. So let's start with some analysis. We're going to do network analysis of the railway, and I see the professor smiling because I told him this story a couple of nights ago, and he's been holding his sides with laughter ever since. Here goes. There is a map of the British railway network, much truncated from its heyday. There were cuts in 1964, but nevertheless, there it is. Now, British Rail, then still nationalised, turned up one day. They went round the backs of the policy unit where I worked, because they knew what we would think about it, and they said that what they wanted was, in today's money, around probably somewhere between $50 and $100 billion to build 2 north-south railway links right through the centre of London. Here is where they wanted to put them on the sort of rather stylised network map that they use. And they produced pages of network analysis showing how much more efficient and profitable the railway would be if these lines were built. And this went sailing through the cabinet because there was no note from the policy unit to say this is all a load of hogwash, because we hadn't been told about it. So when I saw the cabinet minutes, I wrote a 3-line note to the Prime Minister and said, no, this really won't do. I want you to agree that I can stop this and call in the British Rail people and tell them they're not getting the money that the Cabinet has just voted to give them. And she said, yes, MT, on her reply, which was left for me. Now, how in 3 lines could I convince the Prime Minister that these pages of network analysis were wrong, the experts were wrong, the Cabinet were wrong, she was wrong, she'd voted for this, and that instead not a single cent should be paid out? Anyone like to chip in at this point and suggest a reason? Well, the reason was elementary, and this shows the virtue of trying to find the right question and then to ask it. And the right question was, if these north-south railroad lines were so necessary to the railroad network, why hadn't the Victorians who had built the network put them in? Well, the answer, of course, was that they had. There they are on today's network map. And I knew this, but the people who ran the railway didn't. And I knew it because I went and checked. So I called them in, and they said, what do you mean we've got 2 railway lines going through the middle of London, north-south? I said, well, one of them runs from Brighton to Manchester. You run trains in that direction, you know. Brighton to Manchester, page 473 of your own timetable, look it up. And they said, but how does this train get through central London? I said, well, if you had ever travelled by train instead of in the limo in which you arrived at number 10, you would know that the timetable doesn't just tell you where the train starts and ends, it tells you where it goes in between. So they said, well, so where does it go? I said, have a look. And they said, you know, Reigate, Redhill, Croydon, Clapham Junction, Kensington Olympia. How does it get from Clapham Junction to Kensington Olympia, they said. Kensington Railway Bridge, I said. And the experts who ran the railway, it was their job to know this stuff, didn't know that they had a bridge across the Thames, it's fairly visible, on which they were running 2 trains a day in each direction and several dozen freights. They simply had no idea. So the experts don't always get it right. And here is the other one. You can see that hideous structure blocking the classical view of St. Paul's up Ludgate Hill from Ludgate Circus. They didn't know that one existed either. Oh, there can't be a railway line there, they said. It stops at Blackfriars, some way to the south. I said, yes, but it didn't. It did until 1964. It ran right across the front of St. Paul's and then underground and up at King's Cross. You mean there's a tunnel? I said, yes. It runs right alongside the underground tracks. You can still see it there. There's no longer a railway on it, but you can see there was one once. The tunnel's still there. And of course, you've never travelled on the underground, have you? You're too grand. And of course, they hadn't. They hadn't known any of this was there. So I said, and by the way, when you put the tracks back on this, I want you to bury that line underneath and make the tunnel start a bit further down to the south so that we get our view of St. Paul's back. And so they did. And that is now the most profitable railroad line in the whole of Western Europe. Why? Because one advisor wasn't prepared to throw away 50 to 100 billion sterling on a project which was entirely unnecessary. And all it took was knowing the right question to ask. So now, why did the euro fail? This is the next question. You may realize now that you hear, how many Canadian banks have failed in this worldwide banking crisis?
No.
0. God bless Canada. Because you still run things properly here. There's a kind of common sense, down to earth, in Canada, which does not allow the airy-fairy nonsense that happened everywhere else in the world. But my goodness, if you think there's airy-fairy nonsense happened elsewhere in the world, wait till you see what happened in Europe, because they decided to set up the euro. Now, Margaret Thatcher used to say to all her new policy advisors, you have to get the big ones right, dear. There will be consequences if you don't. And one had visions of the cane being brought out. But here is why the first failure of the euro was when Britain tried to join, very much against her will and against our advice, tried to join the exchange rate mechanism of the European monetary system, which was the precursor to the euro. Now, this exchange rate mechanism was as rickety as the Mickey Mouse currency that replaced it would eventually prove to be. But the idea was that the exchange rates of the different currencies, as a way of preparing for the euro, would be locked together so that they could move only a little bit against each other on the markets without the governments coming in and intervening to try and prop them up or push them down, depending. And this was supposed to create conditions that demonstrated to all that the euro would be something that could work. Just one problem with that. At the time when we joined this ludicrous mechanism, we were inflating at 11%. There was a certain political faction that had overspent before the Conservatives came in. I shall not name them, they were called the Socialists. And they had overspent. So we had huge inflation, 11%. The currencies in Europe to which we were supposed to tie ours irrevocably were inflating at 4%. And the theory of all the experts in the Bank of England, in the Treasury, in academia, was that this would impose a sensible discipline on Britain and that we would need to keep our interest rates high so as to bring inflation down. And it was, of course, completely absurd. Why? Because ultimately, in the long run, whatever you may do by trying to fiddle with interest rates in the meantime, the exchange rate of one currency against another is absolutely determined by the inflation differential between those two currencies. And if you have not got the inflation differential down to zero, you can't lock the currencies together in any kind of mechanism and expect that to last. They were trying to repeal the laws of arithmetic, these experts, by saying, in effect, that 11 minus 4 equals 0. And I was giving a talk on this subject at Oxford recently, at the university there. And they also live a little bit in cloud cuckoo land, because I said, does anybody here think that 11 minus 4 actually equals 0? And one bloke put his hand up and said, yeah, I reckon that could be all right. He would make a fine government expert. So we said, don't do it. In the end, they ganged up on Margaret Thatcher and forced her against her will and our advice to do it. The consequences were catastrophic, and we're now seeing the aftershock as the euro goes down. Here's a cartoon on that from the China Daily. So a lot of the dislocation you are seeing on the markets now was because the euro was so appallingly managed when it started. When our attempt to join the mechanism tore it apart, instead of adhering to the economic convergence criteria, first worked out, incidentally, by one of your Québécois economists who wasn't too happy with the currency union here in Canada, they abandoned those criteria because the only country at the time when the euro was set up that was qualified to join was Luxembourg. And that is why, and it's as simple as that, that's why the euro is in the mess that it's in today. Well, that brings me on to the subject which is the kind of main part of the lecture. It is mathematics and the climate. Now here we are faced with a very contentious subject. Goodness knows how it has become so poisonously politicized, but it has, and we've just got to make the best of it. Now settled science looks something like this. There is Euclid's proof of the theorem of Pythagoras. Here is the proof of Aryabhata, a proof without words in the 5th century AD, a Hindu mathematician of great eminence. And you'll see how much simpler and easy to grasp his proof without words is. That is a complete, satisfying proof of Pythagoras' theorem that the square on the hypotenuse there on the left is equal to the sum of the squares on the other two sides there on the right. You don't need any words to describe it. It is true, and that's that. That is settled science. And there is another version. This is by Thabit ibn Qurra, an Islamic mathematician around 950 AD. And here is one by me, which combines elements of those two earlier proofs that you saw, where you have a single pentagon in which you either have two congruent right-angled triangles and the square and the hypotenuse, or you have the two triangles each translated to their new positions and the squares on the other two sides. So again, very simple, very clear. That is settled science because it's proven. But now we get on to the unsettled science that, in my submission, is the climate. And let us first of all look at how temperatures have been running over the last 60 years. We've seen a warming at an equivalent centennial rate of around 1.2 Celsius per century. Now that's well within natural variability. And the IPCC is trying to project that we're going to get something closer to 3 Celsius per century of warming over the coming century. And I call this the IPCC credibility gap. It's the kind of very obvious point that even somebody who has no knowledge of climate science can see for himself. He can see the rate at which the warming has occurred since 1950, when we might have begun to have an influence on the climate. He can see it isn't very much. He can see the IPCC projecting a far greater warming, and that raises a red flag. Why are they doing that? I'm not saying they're wrong to do it, but it raises a question of credibility. So what is agreed and what isn't agreed? In blue, what's agreed is that, roughly speaking, if you double the CO2 in the atmosphere, you will get around 1.2 Celsius of warming. But that's before the contentious bit begins. That's before you take into account what are called temperature feedbacks. And in red there, the official position is that the temperature feedbacks roughly triple the original warming caused by the CO2. And these feedbacks are changes to the climate, which are caused by the mere fact that the climate has been warmed by some other cause. And that either amplifies, as the IPCC imagines, or reduces, as the skeptics imagine, the original warming. And the skeptical position is up there in green, not much change. You might get a very slight increase in warming, but probably on balance it might reduce a little. So you'd be looking at only, say, 0.7, 0.8 Celsius of warming per doubling of CO2, rather than the 1.2 you started with. That is the point on which the science isn't settled. If anybody tries to tell you it is settled, that point is not settled. And here, briefly, is the climate sensitivity equation. You multiply together three parameters to obtain the equilibrium climate sensitivity, the amount of warming you'll get after 2,000 or 3,000 years once you have doubled the CO2 concentration in our own century. And as you'll see, those are the values which the IPCC gives as central estimates to each of those three parameters. And therefore you get their currently estimated warming around 3.26 Kelvin per doubling of CO2 at equilibrium. Right, here is how the three are calculated. I put this slide there so that those of you following this on the video afterwards will have a chance to work through the numbers at rather greater leisure. And I'm going to look at each of these three very briefly, these three parameters. First of all, what's called the radiative forcing. First thing to know about it is it can't be measured. Second thing to know about it is that it's already been reduced in value by 15% over the last dozen years. So they don't know really what that parameter is. It's a guess. Then we come on to the second of the two parameters, the Planck parameter, and the first thing we notice here is that there's a big discrepancy between what theory predicts should be what's called the black body temperature of the moon, that's effectively its surface temperature since it has no atmosphere, and what has been measured by the Lunar Diviner mission at the lunar equator. And doing a little maths there, we can work out that, roughly speaking, the actual temperature of the moon is so low, it's about 193 Kelvin, that you'd need to increase that by 40% to get to the theoretical figure given you by the fundamental equation of radiative transfer. So then we also have, and there you can see it there, and what we're saying here is that because they've got it wrong on the moon, they may also have got it similarly wrong, though perhaps not to the same degree, on Earth. If they have, then that change on its own could greatly reduce the expected climate sensitivity. And once again you notice that this Planck parameter, absolutely crucial because separately feedbacks also depend on it, it can't be measured directly. It can only be derived. And then we have the real bone of contention in the climate debate, which is the feedback gain factor. How much do you multiply the original warming by because of these feedbacks? And there is how the IPCC gets its answer. Once again, these feedbacks cannot be measured directly. We don't even know whether the equation that is used for the mutual amplification of these feedbacks to ramp the temperature up as much as they want to ramp it up is the right equation to use. Doubt is now openly being expressed about that. And if that equation is the wrong one to use, then it may be that we have to rethink whether we're even looking at feedbacks at all. Whether we're not looking instead at a homeostatic process where you can get very big changes in the forcings that drive the temperature in one direction or another, but they won't manage to drive the temperature very far. And here is an indication, it's only one, but it gives you some idea of how little the temperature has changed over the last 750 million years. Now, these changes are quite big enough, 8 Celsius or 3% up or down from the 750 million year mean. They are enough to cause trouble. They can cause ice ages at one moment, and hothouse Earth the next, and somewhere in between the next. But in absolute terms, that 3% change up or down, considering the very large changes, for instance, in the behavior of the sun, would certainly suggest that we're not looking at a very large feedback in the system. We're looking at a much more homeostatic system, rather like your temperature in your body, which tends to vary only by 1/10 of a degree or two either side of nominal, because there are mechanisms in there to make sure that it doesn't. And it's much the same with the Earth herself. So if you were a process engineer, you would expect that in a climate that stable, the feedbacks would be negative in the green box there along the bottom left. Probably somewhere between 0.5 and +1 as your feedback loop gain. That's the closed loop gain in the system. But you'll see the IPCC's values in that red box there are way too close for comfort, to the point at which the climate sensitivity curve shoots upwards towards almost infinity. And that has not really happened, as far as we can tell, at any time in the last 750 million years, and it suggests, therefore, that the basic feedbacks operating in the system are nowhere near that zone. Indeed, if you were a process engineer, you would have a limit of 0.1 absolute maximum for any feedback circuit that you designed, so that it didn't actually exhibit runaway feedback. You'd have a maximum closed loop gain of 0.1, and that is absolutely the limit. And you can see how far above that, in other words, how far to the right of that line, and therefore completely in the realm of fairyland, the IPCC's implicit central estimates of the feedback loop gain actually are. And here is a graph you'll see practically nowhere. What happens when you go beyond the point of singularity in the Bode feedback amplification equation? And the interesting thing about this is that the canonical literature on feedback says, well, it becomes undefined. At the singularity, that's the vertical line in the middle of the graph there, yes, it does. But immediately beyond it, it becomes defined again, and the literature doesn't mention this. And here is this, you'll find this in Bode's book. This is what you get. And so you can, if you want, building an electronic circuit, force the feedbacks to pass either side of the singularity, and you'll get an oscillation in the circuit. And that is used for many purposes in electronics. But in the climate, if you look at how stable it's been in temperature terms over the last 750 million years, it's never crossed that singularity. And that means that the feedbacks simply can't be anything like as net positive as the IPCC so fondly imagines. And indeed, there's a further instance of this, which you see here from Professor Richard Lindzen, the early faint sun paradox. And this paradox says that the sun has very greatly warmed up over the last couple of billion years, and yet temperatures on Earth have not really changed very much over that time. And you can't explain this by CO2. You'll see on some of the extremist websites they try to do it, but you can't. You won't find this in the literature, that you can explain this by CO2. You can't do it. You can do it if you assume some sort of homeostatic mechanism, and in particular, Professor Lindzen has studied this, and he thinks that clouds may be that mechanism. So why then can't computer models predict the climate? Why are they giving us these exaggerated forecasts that really aren't coming to pass? Now, the first reason for this is that the climate behaves as a mathematically chaotic object. And you'll see there the quote from the guy, Edward Lorenz, who was the father of trying to forecast the weather by computer. Edward Lorenz, he was also, in this paper, creating chaos theory. This was the paper in 1963 in a climatological journal which created the new branch of mathematics known as chaos theory. And even if you take a really simple chaotic function like the Mandelbrot fractal here, and we make it draw a picture, starting at the top left with the value of the complex number c that you see, and at the bottom right with another value, which differ only in the last 3 or 4 of a 16-digit precision, you will still get, well, you might get a simple picture, simple equation, but that is what you do get. It's a truly extraordinary picture. Every time the color changes there, that is a bifurcation in the evolution of the object, one which you could not predict unless you knew the starting values of those beginning and ending parameters to a precision which, with the climate, is forever denied to us. You just can't get that precision or anything close to it. And the other thing to note is that even when the values at starting and ending are more or less the same, these bifurcations, rather like, for instance, extreme weather events in the climate, they happen anyway. So if we perturb the climate in some way, they're not going to happen anymore. There's no way of predicting whether they're going to happen anymore in a chaotic object, and no reason to suppose that they will be any more frequent than they already are. And here is what we might conclude about chaos. In climate research and modeling, we should recognize that we are dealing with a coupled nonlinear chaotic system, and the long-term prediction of future climate states is not possible. Now, I'm sure that everyone here would agree with that because it was the IPCC that said so. There we are. They admit that models can't do what they then try to do with models. Now we're going to look at the IPCC and its mathematics. First of all, we're going to the 2007 report. You'll all recognize this as a sine wave. The trend of a sine wave is 0. That's settled science. However, if you take just this segment of the sine wave and start there, the trend is like that. If you start still further to the right, steeper downwards, still further and still further. So what we appear quite falsely to have is an ever more rapidly declining trend. If we simply change the phase of the sine wave, then it appears to be a rising trend. Now you may say, what's this got to do with the IPCC? Watch. They've even used the same colors I have. And here is their 2007 report. This is the principal conclusion of that report. And what it says is that the rate of warming is itself accelerating, and we are to blame. Now, first of all, this technique, we've already demonstrated, it's bogus. You can't draw any conclusion of that kind from using this technique. And therefore, it does not follow that we are to blame for the acceleration in the warming rate, because we have no proof by this method that there is any. Here is what the scientists originally submitted. That's perfectly correct. It's the 150, 60 years roughly of Hadley center temperature change with a single trend line correctly positioned at about 0.4 Celsius per century of warming. Not much of a problem there, but that is what they published. That's what they had from the scientists. So we've got tampering going on, and it's fraudulent tampering, so you might think, because we can apply their same technique to this. And we can have a line going from 1905 to 1945, and another from 1905 to 2005, which is only at half the slope. Phew, global warming is slowing down. Now that's just as bogus a conclusion as the first conclusion. The technique is not satisfactory. Here's the truth. You have 3 parallel, and therefore identical, rates of warming that are quite rapid. 1860 to 1880, 1910 to 1940, and 1976 to 2001. There's been no acceleration in the warming rate. What you have, let's see why that is happening, is there appears to be a superficial correlation between those rapid increases in temperature and the Pacific Decadal Oscillation. You might like to read Sonis et al. 2006 on this. Correlation does not necessarily imply causation. I don't push this further than it's worth. What we can say is there's been no acceleration due to global warming. And as you can see, this is beginning to worry the usual suspects, because they can't understand why there's been no global warming for the last decade or so. Well, the answer is that the natural signal from the declining activity of the sun is not a very strong signal, but it's enough altogether to swamp the rising trend that we would expect from CO2. So now we're going to look at the 2001 report. And I'm going to need a bit of help with this gadget, I think. Right, here is what happened. In 1995, I should say, David Deming published a report in Science about reconstructing past temperatures via borehole measurements from all over the world. And he was congratulated by various people, including a man who said to him, you know, we have to get rid of the medieval warm period. Here's why they wanted to get rid of it, because that's from the 1990 report of the IPCC, and where the exclamation mark is, you can see how much warmer they thought it was, roughly speaking, it's only a schematic this, in the medieval warm period than it is today, the little pimple on the right there with the big depression in temperatures, the little ice age in between. That was the understanding in 1990, but by 2001, that is what had happened. The question mark is where the medieval warm period was. It's been wiped out. And instead, there's a huge uptick in the 20th century, much bigger than what was shown in 1990, and you'll see the little ice age has gone as well. How did they do this? Well, the first thing they did was they gave 390 times as much weighting to the tree ring series of temperature reconstruction data that they were using that gave them that nice uptick in the 20th century than they gave to those that didn't. They also used an algorithm in their computer which would draw that hockey stick shape going up there at the right. Even if you put random red noise in it. Here you've got genuine data at the top, random red noise at the bottom, hard to tell which from t'other. Didn't matter what data you put in, that was the result. Except that even if they did that, they couldn't make the medieval warm period go away. The very faint grey line along the bottom is what they came up with when they took out what they called 20 censored data, 20 series from the hundreds that they used, on which the hockey stick shape depended. If you took those out, the hockey stick shape would disappear. And they knew it. So they put them back in again, made the medieval warming disappear, just like that. And so that's how the trick was done. And then they did something else. They did a trick, which was found in the ClimateGate emails, of interfering with the 20th century, from 1960 onwards, the 20th century temperature records as indicated by the tree rings. Their problem was that the temperature in black there was going up, but the tree ring series were suggesting the temperature was going down. That's the green one there, Briffa et al., for instance, in 1998. And this divergence was a problem. It's mentioned esoterically in the literature. But in the published documents of the IPCC, you'd hardly know it was there. What this divergence shows, of course, is that these tree ring records they were using are wholly unsatisfactory for trying to say what temperatures were before we had instruments to measure them. So this was quite a scandal, which was made worse when the World Meteorological Organization produced this graph, where instead of Briffa's green line going downwards, that was the actual data, it goes upwards to above where the temperature itself had gone. A very, very large discrepancy, which I'm now going to show. The reality is on the left, and the fiddled figure is on the right. Now that's quite serious. And then, of course, this was exposed by two Canadian researchers, Professor Ross McKittrick, who is a joint author with your professor here of a distinguished book, Taken by Storm, Buy One Now, Plug, Plug. It's a very good book, well worth reading. And the next thing that happened when this was all exposed was that a series of papers suspiciously came out, all by modelers, saying there wasn't really a medieval warm period. And so then the House of Representatives in the US investigated, and they found that all the authors of these papers that suspiciously appeared all at the same time were linked by previous co-authorship or other association with the man who had authored the original paper wiping out the medieval warm period. There were too many scientists chasing too little data and doing very strange things with it. Well, was there a medieval warm period? According to this database, which is available online at the address there, yes, there was. And papers by very large numbers of scientists say that there was. And there, just as an indication, is the legal definition of fraud. Now, I am not going to say that what I have just shown to you in any way amounted to a fraud. That, of course, is a matter for the courts. We report, you decide. So then we have a rewriting of consensus in the 1995 report. Here's the before. This is what it said. When will an anthropogenic effect on climate be identified? It's not surprising. The best answer is we do not know. That's honest. That's proper science. Expressing a doubt where there is a doubt. Nothing about settled science in that statement. So that was what the scientists handed in their final report. They said this 5 times in that report. But all 5 of those were wiped out, and that was what the bureaucracy published. They got one scientist, at their request, to rewrite it to say the opposite of what had been found by the scientists. Now, what am I, as an advisor, to tell my Prime Minister about how trustworthy these people at the IPCC are if these kind of games are going on? So then we have the 1990 report, and notice we're going through the major conclusions of each of these 4 reports. Here it is. The observations show not much warming. The predictions by James Hansen to Congress show much more warming than actually happened. Those predictions were echoed by the IPCC in its 1990 first assessment report. How many of you think that in the 5th assessment report they will review their original forecasts and say why it was that they got them so wrong? Don't hold your breath. Here is a forecast done by a simple analysis of cycles by Dr. Nicola Scafetta. His forecast in blue is proving accurate. You can see in red the correct temperatures there, in black his central estimate, and they follow quite well. The IPCC is already, by 2012, way off into outer space. Far too large a forecast. They've got it very badly wrong. If we go back to the Central England temperature record, 1695 to 1735, then over that 40-year period, there was 2.2 Celsius of warming gross, and that's about, once you take the linear trend, 0.4 Celsius per decade. And how much warming did we get in the whole of the 20th century? Only 0.7 Celsius. So let nobody tell you that the rate of warming is unprecedented. No, it isn't. It's well within natural variability. And can you distinguish between these 2 graphs of temperatures, one of which was temperature changes before we could have had any real influence, and the other is after? I'm not only going to tell you which is which, but they look pretty similar to me. So where's the human signal in that? And here, to put it in perspective, is that little orange line is the entire increase in global temperature over the 20th century, plotted against 1 month's actual temperature change in Boston, Massachusetts. You begin to see how trivial these tenths of a degree of change really are. Ocean heat content. They predicted it would rise 4.5 times faster than it has. Sea level. They said we were going to see sea level rise at 1.5 foot, 2 foot, even 3 foot per century. And here, in the last year, it's actually been lower than at any point in the previous 7 years. And the rate at which it's rising is about 3 centimeters per century equivalent over the last 8 years. But you won't have seen that reported anywhere. Here is the extent and trend of global sea ice. Yes, there's been some loss of ice in the Arctic compared with the high point at which they started measuring it in 1979. It was probably a lot lower than even it is today in the 1920s and 30s, not that you'll ever be told that. But if you take the Antarctic, where it's been cooling, put the records together, as the University of Illinois has done here, not much change in the 30-year satellite record. Hurricanes at just about their lowest activity level in the last 30 years since satellites have been watching. Methane stopped rising in the year 2000, almost. And the warming since then, caused by the increase in methane, may turn out to be 1/350th of a Celsius degree, if you believe the IPCC on how much warming methane causes. Aha! So, here is another failed observation, or rather a failed prediction. On the edges, in red, are 11 model predictions, suggesting that the amount of radiation escaping to space will fall as temperature rises. In fact, it rises as temperature rises, so the satellites show. So once again, we have a failure of the IPCC to get this right, and that would imply around 0.7 Celsius of warming, which is about where I think it probably is. So now we're going to look at climate economics very briefly, and we begin with the bird in the hand rule. Now here is Lord Stern writing about the discount rate of 0.1%, which he calls 1.4%. It was actually 0.1 that he used. And you'll see this in a report he wrote in his own economic journal, World Economics. He's one of the editors there, in 2007. And if we look back on that only 5 years ago, at that time he was saying there was a 10% chance that the Earth would not survive the global warming of the 21st century. And all the news media were trotting out this garbage, but nobody was buying it. And now, if you read that, you look back and read it only 5 years, how absurd it looks, how far we have come away from this kind of hysteria. The market discount rate will certainly not be much less than 5%, not 0.1 and not certainly 1.4. So what then is the cost of climate inaction? Well, the first thing is, if we adjust the maximum GDP cost of the damage caused by the warming, if the IPCC is right and we get about 3 Celsius of warming in the 21st century, the maximum cost, says Stern, if that happens, is 3% of GDP. You could get more extreme costs if we got even more warming, but nobody now expects that to happen. And if you adjust for an interest rate, a discount rate, not of 1.4%, which he said he used, but the 5% we should use, then the actual GDP cost of doing nothing about the climate and taking the damage that arises over the 21st century is 0.5% of GDP. That is all. And there is the economic equation that you would use to convert between the two discount rates. And there's a table of different discount rates where you can see 0.5, maybe 1% of GDP, even if you take, say, a 3% discount rate, which some advisors would take, even though it's a bit low. So let's take a case study very briefly, Australia's carbon tax. Now, the big problem with any individual nation trying to act on this is that it doesn't make very much difference, because they're only going to cut their emissions by 5% over a 10-year period. Their emissions are only 1.2% of global emissions, so you're going to get a tiny, tiny, tiny fraction of global emissions actually reduced. We're going to take the IPCC's climatology as normative. We're going to pretend there's going to be as much warming, say around 3 Celsius this century, as they say there will be. And therefore we assume a couple of simple parameters there, which we feed in then to the cost of abating CO2 emissions. And the problem with the Australian scheme is that it will reduce carbon dioxide concentration worldwide from what would otherwise, on business as usual, have been 412 parts per million to, wait for it, 411, 0.987. Big deal. And as you can see, you then run that through the equation, and that gives you an entirely futile amount of warming forestalled, one which cannot be measured, so that even if their policy worked, they'd have no way of telling that it had. And this is what it's going to cost. $1.5 quadrillion per Kelvin of warming forestalled if everyone around the world used measures as cost ineffective as those of Australia, which I assure you are not worse than everybody else's. They're pretty much typical. And here is a few other costs. If you just wanted to forestall the warming that will occur over that 10-year period in the life of the scheme, then you're looking at 309 trillion in cash, 44,000 per capita. I'll have your check now, Professor. Or 57% of global GDP, just to forestall 0.15 Kelvin of warming projected to occur by the IPCC as a result of CO2 over the period. It's 110 times more expensive to intervene with measures such as the Australian cap and trade scheme than to sit back, enjoy the sunshine. Don't you just love the sunshine I brought with me today? That's the Monckton effect. If Gore had come here, you'd be under feet of snow. When Monckton comes, you get the sunshine. Enjoy it. 110 times more expensive to act than not to act on CO2. And if you even look at all the other potential interest rates there, it doesn't, discount rates, I should say, doesn't matter which you take. You can even look at the extreme disaster scenario of Stern and combine that with an extremely low discount rate. And it's still at least 3 times more expensive to act than not to act. So the economic conclusions are very simple. No policy to abate global warming by taxing, trading, regulating, replacing or reducing CO2 will prove cost effective solely on grounds of the welfare benefit from climate mitigation. Mitigation strategies that are inexpensive enough to be affordable will be ineffective. Strategies costly enough to be effective will be unaffordable. Focused adaptation is the sensible way forward. That's what I would recommend to my Prime Minister. The cost of the premium, as they say on the London market, exceeds the cost of the risk, so don't insure. That's as simple as that. But there is also the moral dimension, which I want to end. And this is a rather important dimension. Here is one of our fellow citizens of this planet. This is before the earthquake in Haiti. He was selling mud pies, made with real mud, to his fellow Haitians. They were paying 3 cents each for these mud pies until the doubling of world food prices caused by the biofuel scam, which took billions of acres of agricultural land out of growing food for people like him who desperately need it, and into growing biofuels for clunkers that don't. Result, mud pies up to 6 cents. And if you're poor, you can't afford 6 cents. You might have been able to afford 3, but you can't afford a doubling in only a few years. Caused not by global warming, but by stupid, insensitive, cruel global warming policies, carelessly adopted by nations who ought to know better. And here is what the UN's Right to Food Rapporteur, one of the few officials that I would retain in post when I sweep this lamentable organisation off the face of the planet, said this: when millions are going hungry, it is a crime against humanity. I repeat that, a crime against humanity, that food should be diverted to biofuels. And yet that is what the Greenies have been demanding. It is a scandal, because here is what we could be doing with the money. This lady had her sight restored for $8. She had trichitis. It's a disease caused by the trachoma parasite, which makes the eyelids grow inwards to the eye and pierce the eye. It is acutely infectious, it's acutely painful, and it eventually causes blindness. Does she look unhappy that she's had $8 spent on saving her sight? So what I want to do is to retask the international cooperation that has been achieved, albeit around the wrong problem, so that it faces the right problem. The problem of the children of Africa that you see here now, staring at you with their hopeless, hopeful eyes. They need clean water and safe sewerage now. They need a secure food supply now. They need health care and disease prevention now. They need DDT to prevent malaria now. They need shelter and housing now. They need a good education now. They don't need it in 100 years' time, when we might have a problem from global warming, though I doubt it. These are our fellow citizens of this planet. They need our help now. So if we're going to spend these trillions, can't we please spend them on those who need them most and need our help? I hope and I pray that as a result of arguments like these, deployed by few of us though we be, people will think and think again and do what I would do to my Prime Minister and say, Prime Minister, not another penny for climate change. Every penny is needed to eradicate the poverty which, amid the riches and splendour in which we live, is surely unnecessary and can now be, and should now be, swept away forever. Thank you.
Okay, thank you very much, Christopher. It was quite a wide-ranging talk, and I think it's fair to say that you pushed all the appropriate controversial buttons on every one of these issues. You bored many oxes. It's a bad pun. This is a topic that, at the very end, where we started talking about climate, is something that there are many distinct points of view. And I want to, if you are curious about this and you don't know anything about it, I encourage you to go and look at other sources. You can get other points of view on this. This is not the usual point of view that we'll hear, but that's certainly what we like to do at Nerenberg, is to convey non-standard points of view. Now, the reason why I'm saying this is we do not have the time here. We can take a few questions. We do not have the time to debate every single one of the points that were raised. But we can certainly ask questions about them. So if you have a question, please keep your preambles to a minimum and pose it as a question. Thank you very much. Okay.
I don't know if you're aware, but in Canada...
Please speak up so people can hear.
Yes. I don't know if you're aware, but in Canada there's a plan to actually bury CO2 into the ground. Have you heard of this?
Yes.
The government wants to spend hundreds of millions of dollars doing it.
Reminds me of
Does that
two
make sense?
words. Dream on. It can't be done. It's totally impractical. Even if it could be done, it has a formidable problem. You use 40% more fuel to generate electricity if you also have to divert a large amount of the power towards driving the CO2 underground. And here are people who say that we can't drive small quantities of water and sand underground to extract shale gas, because this fracturing of the rock will cause all sorts of problems which it hasn't caused in the 60 years since the technique began. And yet they say we can pump CO2 under enormous pressure into precisely the same rock strata without doing any harm at all. I wonder what they're on. I'd like to have some.
I'm wondering if you've raised, I think I hope everyone thinks are interesting scientific points about the global warming debate. And I don't follow every paper that's published, but I get the sense that the points you've mentioned here today are not represented in the most reputable magazines like Nature and Science. And I wonder if am I right about that? And if they aren't represented, can you explain why it is that the editors of Nature and Science won't publish the skeptical points?
Money. But to answer your question more carefully, these points are in the literature. There were references on most of those slides. The data, for instance, are the published data. They're not my graphs, they're the graphs published by the IPCC in 1990. Now, I grant you, the IPCC is not peer-reviewed. I'm sorry about that, it should be, in my view. The models it uses are not peer-reviewed. 9/10 of its case is based on those models, which are not peer-reviewed. Nearly a third of all the references it gives to the so-called scientific literature are to literature which is not scientific at all. It's not peer-reviewed. It's children writing student essays. It's activists shambling around the world making stuff up. It's greenie organisations. Now these, I'm sorry, I'm answering the gentleman's question. These organisations are producing reports that are not peer-reviewed, but are being quoted by the IPCC. Now, I don't think that's right. Now, I don't think that's right. Can you be silent? Please be effective in silence.
He's leaving.
He's leaving, that's all right, good. You could have asked a question if you'd stayed. No, you're not to interrupt, I'm answering this gentleman's question. Be silent until I've finished. Now, the point is this, sir, that the IPCC's work is not peer-reviewed in any sense recognised to science. If you send a paper to a journal for peer review, it is sent out to reviewers whom the editors find to be expert in that field. They then write their reviews. If the author then fails to make changes, then the paper does not get published. Now, the IPCC's authors, if they write and then the reviewers say, oh, no, we don't think this is right. We don't think, let us say, that the Himalayan glaciers are going to disappear in only 25 years. Then the IPCC's authors say, we don't care. We want to influence governments. That was, in effect, what Mr. Lau, who was the coordinating lead author of that chapter in the 2007 report, said. He said, we wanted to influence government, so we weren't going to change it. We knew the figure was wrong. So they're putting in figures they know to be wrong, even when the reviewers tell them not to. You can't do that in a properly peer-reviewed document. And it's a fundamental defect in the whole way the IPCC happens. And of course, all the reviewers can look at the drafts, but as I have shown you and given you plain evidence in front of your own eyes, here their principal conclusions on 2 of the 4 occasions I showed you were altered after the final reports of the IPCC scientists had been submitted to the IPCC. And if you ask the IPCC about this, they say, oh, but we sent them to a contact group. And you ask who was on the contact group? Representatives of governments, most of whom have no scientific qualifications whatsoever. So if anyone asked me, should I take the documents of the IPCC seriously, I will merely show the evidence I've shown you here. And if I had shown that to my Prime Minister, she would have withdrawn all funding from the IPCC and would have seen to it that the whole organisation was abolished before it could do any more damage. It is not a scientific organisation. It was set up as a political organisation explicitly by Sir Maurice Strong 25 years ago. He said that that was what he was doing. He did not intend it to be scientific. It wasn't and isn't and never will be scientific. And as soon as it is swept away, the happier I shall be.
Very much. I think, Gordon, you should get a chance to have a few moments to comment and then ask a question, please. Thank you.
I'd like to ask if you've ever asked the distinguished UK scientist, for example, Sir John Houghton.
Yeah, speak up, please. Yeah, louder. We're not hearing you. They're not hearing you.
Sir John Houghton is an eminent British scientist, fellow of the Royal Society, professor at Oxford, as I recall, who told me in my days when I was working with him that he many times went to Chequers and spent the weekends with Margaret Thatcher when she was Prime Minister after you left. Can you tell me if you've ever spoken to Sir John Houghton, and you telling me, are you going to tell this audience that he was a liar?
What I'm going to tell this audience is that he was wrong. As I said, there are many reasons why the experts are wrong some of the time. I'm not saying experts are always wrong. But just because they've got fancy names and titles, that doesn't guarantee that they are right. And it was 2,300 years ago, sir, that the philosopher Aristotle first codified the fallacies of human logic, not the least of which
That's the best move you've made, sir.
was the argumentum ad verecundiam, the argument from false appeal to authority. I don't care what anybody says in science, however eminent they are, if what they say is contradicted by the evidence. The evidence shows beyond a shadow of a doubt that the warming that we have seen over the last generation since the first IPCC report is below the lowest estimate of the IPCC. Now that means they got it wrong.
Can you stop using this for 1 minute?
Just a moment.
Wait
I'm
a
going to
minute,
finish the
wait a
answer,
minute.
then we will take another question.
Excuse me.
And
Excuse
when
me,
it
I'll
is
give you a
clear-
chance in a moment.
When it is clear that the data themselves do not bear out the forecasts that were made, then what is the first task of the organisation that made those forecasts? It is to think why it got those forecasts wrong. But I have read the relevant chapters of the zeroth order draft of the fifth assessment report. No such analysis is contemplated or attempted. It should be. They cannot go on making ever more exaggerated predictions when their past predictions have already proven to be so howlingly exaggerated. So let us get this back to the level of science and not of pleading reputations in aid. That's my answer on that one.
Okay, I'd just like to give the floor for a moment to our Dean, Charmaine Dean.
It's great to hear the debate going on here. If we could just try to keep the aggression at a reasonable level, whatever reasonable you think that might be, that would be helpful. Let's debate this without, casting dispersions on individuals' characters. So we're really pleased to have a debate going here. So let's try to keep it without talking emotionally amongst each other and maybe talking about integrity and so on. So let's...
Thank you, Jermaine. I agree with that completely. Okay. Now,
Thank you very much, Madam Dean.
I'm looking for statement, not statements, but questions. And if you want to have a short preamble to explain it, I welcome that. But please try to focus on asking a question that will bring out important issues here. You have made a couple of comments. I'll give you the floor for a moment.
In your view,
Louder, please. Louder, please.
In your view, is global warming happening or isn't it? Do you think your charts and graphs prove it is not?
No, sir. I've shown you graphs going... Yes, the question, I'm sorry, is whether I think that global warming is happening. For the last 15 years, no, it hasn't been. But for the last 300 years, it has been. For the last 25,000 years, it has been. For the last 15,000 years, it has been. It depends on where you start. You need to be more precise. Since 1950 is a good place to start. That's where the IPCC starts its consideration of what influence we might have had on the climate, because really before that, we couldn't have had much. And since 1950, the rate of increase in global temperature, expressed as a centennial rate, which is one way of doing it, is around 1.2 Celsius per century. And that is a real rate of warming. It has been measured. And I showed it to you on the graphs there. Now the question is this: what is causing that warming? Is it us or is it nature? As I showed you in the Central England temperature record, before we had instruments anywhere else, we saw a much greater rate of warming, many times greater than anything we've seen in the 20th century. So the warming that we've seen so far is well within natural variability. And it's not for me to say that it's entirely natural, entirely man-made, or somewhere in between. The IPCC may well be right that most of that warming since 1950 was caused by us. That's one of its principal conclusions in the 2007 report. I am not in a position as a layman to argue against that. All I would say, though, that is if that is all the rate of warming we've seen since 1950, it's quite a big stretch to imagine that suddenly that rate of warming is nearly going to triple over the 21st century, when in the first 1/9 of that century there has been no warming whatsoever.
Okay, there was a question over here, and remembering the ground rules that I've been asking for, please.
Thank you. At the beginning of your lecture, you told us to imagine that we were the Prime Minister of England and you were our advisors. So thinking about that, I figured, what would I want to do after hearing what you said? And one thing I would want to do is check how scientists interpret the conclusions from the reviewed journals that you referenced in this presentation and other presentations that you've done. Before coming here, I watched a video by a professor at University of St. Thomas, John Abraham. You probably have seen his review of one of your other presentations. He goes through the different
yeah, please come to a question.
Sorry, so the point is the material that you cite is often given an interpretation that goes in conflict with the scientists' views who actually produce the science that you cite. So as a Prime Minister, I would ask myself, why is it that the advisor interprets the science so differently than the scientists, and why should I hear you?
I think that's the question.
Why is he speaking differently than the experts, if I may characterize?
Well, as I've said, first of all...
Just to clarify, sorry, that's not my question. My question is not just why your view is different, but why your view of their work conflicts with their own view. You cite them, but they say you're wrong. So
well, no. All right. Thank you very much. No.
Okay, but I think it's fair enough that ultimately there's one view. There's what you call the scientist's view, and the Prime Minister wants to know why there's a difference.
Yes, that's a perfectly fair question. Though the reference to Professor Abraham was perhaps unfortunate in that you omitted to remind everyone that he is not a climate scientist any more than I am. And that also, I have produced a very long and very clear, point-by-point refutation of what he said. I don't know how he came to do what he did, But I will say this, in the 8 months he says he spent doing it, not once did he contact me to ask for clarification on any point. He made a number of assumptions which were wrong. He put those assumptions to third-party scientists and got some very hostile reactions back because he had simply made up what I had said. He then used those against me in his talk. It was intellectually disreputable in the extreme. You've asked your question, sir. I'm now going to answer it. We'll then let somebody else have his turn. So the question is then, there are some scientists who say there's a problem, there are some scientists who say there are not, and there are people like me who have no qualifications in the relevant subjects who also say there is not. How do we decide who is right? Well, we look at the kind of evidence that I've put in front of you today. And if we take the example, for instance, of that graph from the 2007 report where 4 trend lines have been messed around with so that arbitrary starting places were taken so as to try falsely to show an acceleration in the warming rate which is not there in reality, then that is something which any statistician can report on. And in fact, before I go to the police with this particular piece of wrongdoing as I see it, I have, of course, as a first step, anonymized the data and sent it to an expert statistician. And his answer was that, of course, they can't do what I told him they had done. They can't use those multiple trend lines chosen arbitrarily by them in that way, when you could equally choose other trend lines arbitrarily and come to a precisely opposite conclusion. That is an impermissible statistical technique. Now, the method which I have used in order to evaluate the conclusions to which I have come, which is going and checking with the relevant expert, in this case a statistician, is a method which is available to all of you. You can check any of the points I've made and go to an expert, but don't go to somebody who purely shares your political point of view. Go to somebody who is genuinely going to give you an independent and authoritative assessment. That's the fairest way to do it. What I have tried to show you here has been fairly put together and honestly put together. For instance, where I showed you the way they abolished the medieval warm period, it would be clear to anyone with an honest eye looking at what I have shown you that very serious questions arise as to the integrity of the scientific process by which the medieval warm period appeared to have been, quite falsely, abolished. And you can then go and check with the 2 Canadian scientists, one of whom I dined with a few nights ago to make sure that I had understood correctly the points that I put to you today. Behind these presentations is no political manoeuvring, but a great deal of talking to the scientist expert in the field, so that if I come to a conclusion about a thing, I go and check it. Sometimes I'm wrong. If it's already crept into one of my presentations, it comes out. But I've been doing this for some time now, so I hope that by now most of it is right. All of it is well sourced and readily verifiable. I do ask the honourable gentleman to feel free to check. Thank you, sir, for your question.
It is true that sometimes he is wrong, and sometimes he's right too. So, any more questions? Yes, John.
I watch YouTube too, so I'm an expert, obviously. My question is how to get this message to become Coney 2013? Where's Monckton 2013 to get the message out? Because looking at the room here, I think my daughter's the youngest one here. How do we make this jazzy and catchy and get this to be the next thing that actually does some good in the world, not the questionable good we've had thus far?
Lovely question. How do we do to get what I do believe to be the truth to be more widely disseminated and to be packaged in a cooler way? I could have turned up in biker gear here today. That might have helped. On the other hand, it might not. So I think the point is that what I do is try to work out what the truth is and then talk very plain language to say what I think it is. And that's how I function. I don't do spin. I don't do PR. It's not my job to work out how to put messages out. If somebody comes and asks me to give a talk, I'll turn up and give one, if I can. If they don't ask me, I'm not knocking on the door saying, hello, I should be giving that lecture next year. So I don't do PR. It's a very reasonable question, in that there's a real problem here with near unanimity, so it appears, on one side and not enough of a voice on the other. There should be some way of getting the other voice out. But within the scientific community, the debate is in fact much more evenly divided than you may have been misled into believing by the endless repetitions of "there's a consensus" in the baby press. The fact is, "there's a consensus" is intellectual baby talk. Aristotle again codified that one as the argumentum ad populum, the head count fallacy. Just because you're told a lot of people say they believe a thing is true, doesn't mean there are a lot of people, doesn't mean they say it. Even if they say it, they may not necessarily think it. Even if they think it, they may be wrong. The fact of a consensus, even if there were one, tells you absolutely nothing about the truth or falsehood of the proposition to which that consensus is said to assent. That's a very important thing to understand. Now, if you are of a certain political cast of mind, I call them the Borg, the people who think, once they're told what the party line is, they turn off their minds and stop thinking. Then it doesn't matter what anyone says or how coolly you dress up the message, they'll say, no, the party line says this, and until somebody from the Communist Party headquarters tells me the party line has changed, that's the line I'm going to follow. Or it might be Green Party headquarters these days. They're more or less the same thing. I'm being a little naughty there, but you know what I'm thinking. So the point is, where is the balance of opinion in science? Well, now there are two questions which the advisor would raise here. The first question, you're trying to get the right question. First question is, how much warming are we going to get? And on that, there are only a few dozen scientists who have studied the matter to the length of getting anything published in a reviewed scientific journal. And among those dozens, about half are modelers. And they say there's a problem, and please can we have another £1 trillion for our next big computer. And the other half are the empiricists who, like me, do their science in the old-fashioned way, by measurement, observation, experiment, and the application of proven and established theory to the results. And among the empiricists, the old-fashioned scientists, it is pretty much, it's not quite unanimous, I can think of one or two papers that go the other way, but it's pretty much unanimous that we don't have a problem anything like as big as we're being told. Now, as for all the others chattering away around the edges of the debate, most of them have never studied the climate sensitivity question to a sufficient depth to be able to have an opinion of their own on it. And they are merely then, whichever direction, an echo chamber for those who have. So that's the first question. The second question is the economic question. Even if the warming we're going to get is as great as we are being led to believe, then how much can we do about it, and at what cost? And here, those who do science by consensus are forced to conclude that there's nothing we can do, because it's near unanimous in the economic peer-reviewed literature that has attempted to cost the doing nothing on global warming as against taking action on global warming. It is near unanimous that it is cheaper to do nothing. William Nordhaus wrote a paper from Yale just a few weeks ago saying that in terms of the ratio of benefit to cost, the best thing to do is nothing for 50 years. Now, he later said, oh, well, but I didn't really mean that. No, people have been getting at me, and so I better say that that's not the way we would normally do the analysis in economics. Yes, in this particular case, it is. And the fact is, there is no way that it makes any sense to spend a single red cent of other people's money on making global warming go away for now. Better to sit back, enjoy the Monckton effect, and wait and see. Thank you, sir.